All right, so in this video, we're going to talk about how to find the domains of various functions. So for this video, I'm going to focus on the first 4 functions, and then I'll answer the rest in another video. So let's start with this one. We have f equals x plus 3. What is the domain of this function? Now, when you hear the term domain, you're asking yourself, what are the possible values of x? Can x be 1? Now, if x is equal to 1, then f of x will be 1 plus 3. It gives us an answer. Okay, what are the possible values of x that will give us a definite answer? Okay, if x is, let's say, 0, f of x will be 0 plus 3, which gives us 3. If x is, let's say, negative 5, so negative 5 plus 3, that gives us a negative 2. So we see that x can be any number actually. Now, for the domain of this function, we can say, x is all real, all real numbers. Okay, x is all real numbers. X can be x. We can have something like this. We can use the set builder annotation. This right like this. X and then x is all real numbers. Or we can also use the interval notation, where we can have from a negative infinity. Sorry, why is it? Okay, we can have from a negative infinity and then infinity, or just positive infinity. So it means that x can be any real number. Okay, from a negative 1,000, a negative this, up to 1, 2, 3, 4, 5. It can be any real number. Okay, so for this one, x is all real numbers. So that will be the domain of this function. Now let's go to the next one. Here we have x plus 3 over x plus 1, x minus 1. So what we see here is that there's a fraction. Now, what will be the domain of this function? The thing we ask ourselves is that for a fraction, what will make this function undefined? If you think about it, what will make this function undefined? That will happen when the denominator is equal to 0. When the denominator, let's say we have 2 over 0 now. If the denominator is equal to 0, then this is undefined. You can't really do this mathematically. Okay, this is undefined. So it means that for this function, if this is equal to 0, okay, then the function is undefined. So for the domain of this function, we will have to make sure that this is not equal to 0. So let's see. So we have x minus 1 is equal to 0, and then we can move the minus 1 to the other side, and then this becomes x equals 1. So it means that for the domain of this function, x should not be equal to 1, because if x is equal to 1, that will make this 1 minus 1. So let's see, we have 1 plus 3 over 1 minus 1. This will be 4 over 0, and this will be undefined. So this means that x can be any other number, but it cannot be 1. Okay, it can be greater than 1, it can be less than 1, but x, it cannot be 1. Okay, so we can have something like this, where we can have something like this where, for the domain of this function, so x can be less than 1, okay, and x can be greater than 1, but x cannot be equal to 1. Okay, and then we can also have something like this. If you want to write it in interval notation, you have something like this: from negative infinity up onto 1, but 1 is not included. 1 infinity. Okay, so this means that x can be any number except 1. So that will be the domain of this function. Okay, so I think we can go to other questions. X less than 1, and or we can also do this on a, let me also use a number line. Okay, let's look at 0, 1, 2, 3, -1, -1, -2, -3. So you can see we can draw a circle at 1 where x can be greater than 1, going like this. X can be less than 1, but x cannot be equal to 1. So we don't shade this circle. Okay, it can go towards the right of the circle, it can go towards the left of the circle, but it cannot be, you don't shade that particular circle at 1. All right, let's go to the next question. I can put an or here. Now here we have a square root. Okay, we have f of x equals x minus 9. So to explain this, let's start with something like this. If I'm asked what is the square root of 16, the square root of 16, let's say plus or minus 4. It could be 4, it could be plus 4, it could be minus 4. What is the square root of a negative 16? Now you could decide to use imaginary numbers like I to do that, but generally speaking, this will also be undefined. Okay, because it doesn't really exist. The square, sorry, undefined. The square root of a negative numbers doesn't really exist. Okay, so if you put this on your calculator, you will get an error. But if you're dealing with complex numbers, if you're dealing with complex number, you get something like 4i, but that's for another topic. Okay, but generally you get an error. And then what will be the square root of 0? The square root of 0 is 0. Now, to find the domain of a square root function, it means the value inside here cannot be a negative number. It can be 0. Okay, it can be at least 0 or more. So it means that x minus 9 should be greater than or equal to 0. Because if whatever is here is less than 0, it means we're going to have a negative number. And finding the square root of a negative number will give us an error. It will be undefined unless we're using imaginary numbers. All right, so x minus 9 is greater than or equal to 0. We can move the minus 9 to the other side. This becomes x is greater than or equal to 9. And that's it. So it means that for the domain of this function, so x is all real numbers such that x is greater than or equal to 9. And then for the interval notation, we can have something like this: 9 and then up to infinity. So 9 is included, so we're going to use a square bracket. 9 is included. You can see this is greater than or equal to 9, so 9 is included. And then we just put infinity here. Sorry about my handwriting, it's a bit messy, but this is it. And let's test it. Let's pick a number that's less than 9 and see what happens. If we pick a number that's less than 9, let's say 6. Okay. So let's assume that we pick 6 now. So x is equal to 6. So we have the square root of 6 minus 9. What is 6 minus 9? That would be -3. And we have a negative number here. We won't be able to find the square root of a negative number. So you can see that, so the value of x should be at least 9. So at least we get 9 minus 9, which is square root of 0, which is 0. We have an answer. So you can see there are reasons for this. And if we get the graph, let me see if I can get the graph quickly. For the square root of x minus 9, I'm going to use the Desmos graph. Please bear with me for the delay. I'm just going to, okay, sorry. I just want to make sure I'm explaining this well. Okay, sorry. So you can see the graph here. You can see the graph itself starts from 9, and everything like below 9 is non-existent here. It starts from 9 and then goes, you see 9, 10, 11, it goes to infinity. So that's why you can see here that for the domain of this function, x should be greater than or equal to 9. Anything less than 9, it doesn't fit into the function. Okay, now let's try this one. This one is kind of a mixture of two things now. We have a quadratic equation and we have a fraction. Now again, since this is a fraction, okay, what will make this function undefined is when the denominator here is equal to 0. Okay, and if we do that, we have x squared minus 5x plus 6 is equal to 0. All right, so let's try and factorize this. Okay, the coefficient of x squared here is 1, so what is 1 times 6? 6. So we have to think of two numbers that if you multiply them together, you get 6. If you add them together, you get -5. Multiply them together, you get 6. Add them together, you get -5. That will be -2 and -3. If you multiply this, you get 6. -2 plus -3. That will be -2 minus 3. That will be -5. So it means now that we can split this into x squared minus 2x minus 3x plus 6. We can now factorize each of them. So I say x is common here, x plus 2. A negative, what else is common here? I can say, so this is x minus 2, sorry. My bad, x minus 2. And then we have -3 x minus 2, because -3 times -2 will give you +6 equals 0. So we have x minus 2 bracket x minus 3 equals 0. Okay, we're not done. So for this to be equal to 0, it means that either x minus 2 is equal to 0 or x minus 3 is equal to 0. We can bring this here. This becomes x is equal to 2 or x is equal to 3. Now this means that the value of x, when we were talking about the domain of this function, x cannot be equal to 2 or x cannot be equal to 3. Because if x is equal to 2 or 3, then the denominator here is going to be 0 and the function is going to be undefined. So here, for the domain of this function, x, okay, can be all real numbers except 2 and 3. So x cannot be 2, and x cannot be 3. Okay, so you can write it like this. So x all real numbers such that x is not equal to 2, x is not equal to 3. I just prefer to write it like this. Okay. And then for the interval notation, this one you have 3 brackets. So like this, from negative infinity up 1 to 2, where 2 is not included. So we have a union, 2, 3, and then another union. Sorry, I keep forgetting at the union, and then 3, infinity. Okay, because 2 and 3 are not included. X can neither be 2 nor 3. Okay, so it can be from a negative infinity up 1 to 2. It can be between 2 and 3. So example, let's say 2.2, 2.5 and stuff like that. Okay, then it can be 3, but then from 3, then we have should be above 3. Yeah, could work. So I'll write this again, negative infinity, 2, union, 2, 3, union, 3, infinity. And this is it. This will be the answer. All right, so I hope I've explained this well. I'll explain these functions in a different video in the next video. So I'll put the link in the description so you can follow up. So I hope this helps, and I hope I've been able to explain it well. Sorry about my voice and my writing, but I really hope I've been able to explain it. Thank you and have a nice day.